Gautam, and guys, today we will be doing part 2 of our emotion AI. So let's begin. So what did we do in the last part? In the last part, we imported necessary libraries, we imported the data, understood how the data works and what is the data, plotted the images with key facial parts, altered the data such as flipping images and increasing brightness randomly to provide noise. Then, today we are going to be looking at the test state split and understanding the res block function, or the residual block with its convolutional block, and then how all the blocks come together. So, the test trait split, we basically split the data into the train and test. So in this case, 95% of the data is in the train, 5% is in the test. The 95% of the train data will be given to the model. The model will then will predict the last 5%, and we'll compare the model's predictions to the actual 5% to see how it stacks up. So let's begin. So this is the function res block, which is a key component in the residual neural network, or ResNet. We are going to be using neural networks to understand this. I'm going to link a video in the description which helps you understand neural networks, and I will be making a video after this about talking more about neural networks as we go on into the code. So here's a breakdown. So the purpose of the residual block. So traditional neural networks can suffer from degradation issues as they get deeper. So as you add more layers to the network, the weights get kind of screwed up. And second, residual blocks address this by introducing a shortcut connection that allows the information to flow directly from the input of the block to its output. This shortcut path helps the network learn the identity of mapping, basically not change the input, and facilitates a better training of deeper networks. So let's break down the code. So first we import all the necessary modules, and then the res block. So the three arguments. X is the input tensor to the residual block. Filter is a list containing the numbers of filters for each convolutional layer within the block, which is usually 3. Stage, an integer representing the stage number of the block used for naming layers. Okay, then the shortcut path, X copy. So a copy of the input X copy is created. This copy is passed to a 1-by-1 convolution and max pooling to match the dimensions of the main path after the first convolution. Remember, we are trying to make sure that the residual blocks create a shortcut connection that allows the information to flow directly from the input of the block to its output. We do not want to alter the input. Then, the main path, X. The input X goes to 3 convolutional layers with a different filter sizes as specified in filter with F1, F2, F3, and activation functions. So we put it through F1, then we put it to F2, and then we put it to F3. Then batch normalization is applied after each convolution for better training stability. So basically the batch is the amount of data trained at a time. We change the batch number to stability. Then adding the paths, the output of the main path X and the processed X copy are added together. This addition allows the blocks to learn the identity mapping or residuals on top of the original input. So we basically put our data X into the we convolute it and pool it with the weights with the filters F1, F2, F3, and then we put it back with our original data. So this addition allows the block to learn the identity of mapping or residuals on top of the original input. The sum is then passed to an activation function, which is ReLU in this case. So the identity blocks. This code includes 2 additional identity blocks within the residual block. These blocks follow the same structure as the main path, but without the shortcut connection. So basically these are just redoing this 3 layers. So we do it once, then we create a new X copy, do it again, add them together, do it again, and add them together. Then the final output. We take the input shape of the image, so basically 9696 like we did in the last video. We zero pad it, then we basically stage everything, so basically initializing, and then making sure the batch activating ReLU, making sure that it's good. Then we flatten the whole neural network, and then we output the summary of the model we created. So convolutional 1, res 2, res 2 conv b, res 2 conv copy, res 2, then res batch 2 conv copy. So basically we have res 1, res 2, and then res3. So the 3 ResNets we've created, and on top of these are layers. So basically, we created a neural network that is basically just ready to be trained. It takes in the data and then makes sure it passes it through and pulls it together so that it's able to learn. How does a neural network work? A neural network basically works as when you input an image, it will analyze it and then it will send it on to the next neuron. So basically, how do neurons communicate? They basically send signals to each other. We put pre-weights. We put like weights. So basically, if we're trying to identify a cat, we put a positive weight for like ears, a pointy nose, and a land animal, and negative weights for like a sea animal, like water or like 7 legs. This, with our original weights, the model then learns whether to change the weights or whether the weights are good. So after the model is given all the training data, it is finally has a set of weights that put out the best output. So how do these come together? The main path with its convolutions and activations perform the core feature extraction. Then the shortcut path right here. The shortcut paths then allow the gradient to flow directly to the block, which trains deeper networks. And the combination of these paths along with the optional identity blocks enables the residual block to learn more complex representations of the input data. By stacking multiple res blocks with increased filter sizes, the overall network is hierarchical and it can improve its performance on image recognition. So this is the res block function. If you have any questions, put it in the comments. I'll be glad to answer. This is Coding with Gautam. Thank you and have a good day.